I am going to use the fundamental counting rule for this problem. And the fundamental counting rule says if you've got m ways you can do one thing and n ways to do something else, your total number of possibility is m times n. For example, if you have 5 shirts and 3 pair of pants, you got 15 outfits. So on this problem, we're trying to figure out how many ways, how many different strings of letters we can have. And they have that second condition that says you can't have the I's next to each other. So how many letters have I got? I've got 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So I can put an I here. I'm going to look at all my ways to where my I's would be separated. And I could put an I there, 1, 2, 3, 4, 5. Or an I here and an I there, 1, 2, 3, 4, 5. And an I here and an I here. 1, 2, 3, 4, 5. Or I could have an I here and an I here. 1, 2, 3, 4, 5. I could have an I here and an I here. 1, 2, 3, 4, 5. An I here and an I here. So let's go back. I've used my I's. That means for this spot right here, how many choices do I have left? Well, I've used my I's. I've got 3 choices left, a D, G, and T. So I got 3 choices. And then how many choices do I have left for here? 2, and then 1 here. And that's going to be the case for each of these. So 3 times 2 is 6 times 1 is 6. And I've got 1, 2, 3, 4, 5, 6. They're all going to be the same. 6 times 6 is 36. And that's taking me 1 minute and 53 seconds. So it might have seemed like I'm spending a lot of time doing this, but I think it's easier than me working it as a permutation because I'm not sure if everybody would understand that.